Hi, my name is Yue, and I'm a physics grad student at the University of Michigan. Today, I would like to present to you a story of ice in a warming world. Before I start, you might want to ask, what do you mean by ice? Well, if you look at this map, everything that's white, yellow, or pink is ice. To name a few places, there's Antarctica, there's Greenland, and there's also Arctic Sea, which is frozen almost year-round. Plus, there are many snow-covered mountains all around the world. So all of the ice has been sitting there happily for millions of years until quite recently our planet starts to warm up. This map shows the temperature difference between 2012 and 1901, with red being warmer and blue being colder. Apparently, almost every single location is warmer than it used to be a century ago, and the temperature increase is about 1 degree Celsius. How important is this 1 degree? Well, it's large enough to change the annual average temperature from below the freezing point of water to above. Now, let's sit back and think. What would happen to ice if the environment warms up? As a kid, we all learned that ice in a warm environment will melt, and the warmer it is, the faster it melts. Now think about the entire world and all of the ice in it. If ice becomes water and water goes into the ocean, sea level rises. Just in case you're confused, here's an example that you can do at your home to help you understand how global warming could lead to sea level rise. If you could fill a jar with some water and then let a bunch of ice cubes melt into it. After a while, you'll see that the water level rises. And this is exactly how sea level rise works. Hopefully, at this moment, you've given sea level rise a bit more credit. Now let's take a look at how well our communities are prepared for this. This map pretty much summarizes how vulnerable the coastal areas are to sea level rise. Blue means doing okay and relatively safe, while red indicates danger and rings the alarm. You probably have already noticed that most of the red and orange dots are concentrated along the east coast of the United States. Now let's zoom in and take a look at what the cities are there. Well, to name a few, there's New York City, there's New Orleans, and there's Miami. For example, what would 1 meter of sea level rise do to New York City and New Jersey? So in this map, darker blue indicates the actual ocean and the lighter blue shows flooded areas. You can see that areas along the Hudson River and quite a few places in New Jersey will be submerged underwater. So basically, this is not looking good. Okay, if 1 meter of sea level rise could do this to our cities, how much ice is there in the entire world? Is it possible to raise sea level by more than 1 meter? Calm down. Allow me to do the calculations for you. So, I can tell you that there's about 30 million cubic kilometers of ice on Earth. But what does that mean? So, if one day someone's happy and decided to give every single person on Earth some ice, then everybody can get about 10,000 trucks of ice. And what does this translate into sea level rise? Well, the total ice on Earth has the potential to rise sea level by about 70 meters, which is the same height as a 23-story building. Now you might panic, but don't be, because sea level rise can be predicted by studying how glaciers lose ice. This is an event where a huge chunk of ice broke off from a glacier in Greenland. In this particular event, the size of the ice that broke off was about the size of Manhattan. But the good thing about this clip is that it shows us that ice on Earth can be monitored, so the amount of sea level rise can also be predicted. So what our group does is we take two numbers from a glacier location. And the two numbers are, first, how deep the water is, and second, how thick the ice is. So with those two magic numbers at hand, we could use our computers to do the calculations for us and tell us how fast a glacier is losing ice. Eventually, if we perform this calculation to all of the ice bodies on Earth, we can tell how fast the sea level rises. But before we can do anything, we need data. There are many different ways to monitor ice. For example, there are a bunch of satellites circling around the globe, and people have sent up planes to fly across polar areas, and there are a bunch of research vessels, and most of all, a lot of scientists that are dedicated to polar research. And I would like to express my gratitude towards all of the hardworking scientists, because without their generosity, our research project wouldn't be possible. Before I end my talk, I'd like to emphasize that climate science is real science, and there are plenty of things to do on our side. Plus, who would want to see this cute polar bear lose his home, right? Thank you so much for your attention, and a big thank you to everybody who put together such an amazing workshop and made it possible for me to share my research to the broader public.